Okay, in this section, for this last part of 2.7, we're going to talk about the horizontal line test and then graphing inverses and domain restricted inverses. So the first thing is the horizontal line test. Now, early in one of the earlier sections, we talked about a vertical line test, and that determined whether or not a given graph was a function or not a function. So now what we're going to look at is the horizontal line test. Now, what this test does is this test decides whether or not the inverse of an equation is a function. Okay. Ideally, we like to have an original that is a function and an inverse that is also a function. We like functions to go with functions, but that doesn't always happen. So the horizontal line test is built to decide whether or not the inverse is function. Now, please understand that if something fails the horizontal line test, okay, so it touches in more than one spot, that does not mean that the inverse does not exist. It just means that the inverse is not a function. Everything's got an inverse. Okay, like we can make inverse graphs for everything. It's just whether or not that inverse graph picture is also going to be a function, which is what we're looking at. Okay, so we're going to take a look at two examples here, and we are going to talk about which one of these have inverse functions and which ones, and then we'll also talk about how to graph these. Okay. So over here on my lovely board, the first graph shape that we had was a V-shaped graph, okay? And so when I do the horizontal line test, as I pass this over, there are several places, but that would be one of them where that hits twice, okay? So the inverse is not a function. Okay. Now, the second one that we had looks kind of like this. And this is a taper tail that's happening on this one. If I do my horizontal line test on this, and again, that is a taper tail down here on the bottom, so it actually keeps decreasing over there. This one does pass. So the inverse is a function. Okay. Now let's talk about how to actually graph the inverses of these. Now, one of the things that was mentioned in one of the previous ones is that the domain of a function becomes the range of the inverse, and the range of a function becomes the domain of the inverse. Okay. So basically what we're doing here is we're switching X's and Y's. And we saw that same thing also when we were creating. Okay, we were creating an inverse graph, or an inverse function. Now, the way that we do this graphically, okay, is we're going to reflect across the line y equals x, okay, and that is the 45-degree angle line that cuts right through quadrants 1 and 3, okay. So what's going to happen here is if we look at the reflection, this straight line piece, when it reflects over, is going to come down this way. And this piece that's actually on the line is going to stay on the line. So this is the reflection over that dashed line for this function. Now, looking at the red one, we can see where it is going to fail the vertical line test in several places. But again, we knew that it was not a function anyways, because of that. Now, for this one, I can see that, this kind of gets close and then it's arching away. And then this piece is kind of coming down and hugging right against the line. So that's what I'm going to do with this one. I'm going to make this graph come kind of arch against the line. And so there is what that one's inverse. So again, the red is the inverse and the black was the original. And we are reflecting over that diagonal line. It is not a rotation. Okay, please don't think that, because a lot of times we see like these V-shaped graphs and we think, oh, they just turned 90 degrees. That's not what's happening. This piece is what became this piece, and then that solid line stayed on itself because it was on the dashed. Okay, now the last thing we've got to talk about is domain restricted spots. Okay, and for domain restricted functions, the reason that they will do this is that the graph for the equation that they want to discuss has an inverse that won't be a function. Okay, so kind of a classic traditional one that we see is, say, a parabola that looks like this. Okay, now if I were to go ahead and try and reflect this over that diagonal line, we would have, you know, okay, so we would have that this would arch this way. Okay, I can see that little piece where it would reflect over. This would reflect this way, and this would actually reflect down. So it's still going to have that. Now the problem is that the black one is a function, but it fails the horizontal line test. And now that I've graphed the inverse, we can tell that that is also now the red one's going to fail. So what they will do is they will put a domain restriction on here, and they'll say only look when x is less than or equal to 0. So basically what they're doing here is they're getting rid of part of the graph. Okay, so now instead of having all of that graph, I'll only have this piece, which means this part of that inverse no longer exists because that's not part of the domain. So now what we've created is a function. So this is a function. It also passes our horizontal line test, which means its inverse is going to pass the vertical test. So now we have a function with an inverse that is also a function. And that is something that we do like to have.